In this video, I will talk about duration and convexity and how to compute them. Duration and convexity both are risk measures of a fixed income security, which means higher are duration and convexity, higher is the risk of the security, and hence a higher return is expected. To be short, duration is a short-term or day-to-day risk, and convexity is a longer-term risk. Let's take a fixed-rate bond as an example. We talked about fixed-rate bonds before, which is a bond that pays a fixed amount of coupons. There are various ways to compute duration. In this video, I will talk about three popular ones: Macaulay duration, key rate duration, and effective duration. The most commonly known is the Macaulay duration. The Macaulay duration is named after Frederick Macaulay for his work in 1938. It is defined as the percentage change of the price of the bond over the percentage change of its own yield. The yield of the bond is the internal rate of return, and the price-yield relationship can be explained by this formula, where the cash flow is coupon before maturity and coupon plus principal at maturity. The formula can be plotted like this, which is a convex function. For a given bond price, we can solve the above equation to get the yield. As I shall show you later, the Macaulay duration is the slope tangent to the curve. The Macaulay duration is defined as the percentage change in price over the percentage change in 1 plus yield, which can be regarded as the differentiation of price with respect to 1 plus y, then divided by price and multiplied by 1 plus y. Given the price-yield formula shown earlier, the differentiation of price with respect to 1 plus y is to move I to the numerator, and I becomes I plus 1, which gives this result, and we can further simplify it as substituting the price for 1 and dividing simultaneously by the price. We can then rewrite the equation as a weighted average of times, where the weights are defined as this equation and the weights sum to 1. Let's remind ourselves the definition of the Macaulay duration. Now we just substitute in the differentiation result, and then we cancel price from both numerator and denominator, and then 1 plus y the same way, and then change signs from negative to positive. Then we get the Macaulay duration result, which is the weighted average of times. As previously shown, to compute the Macaulay duration, we need the price of the bond in order to compute the yield of the bond. But how do we get the price of the bond? The first possibility is to get it from the market directly. If the bond is traded, then it must have a price. But due to complex trading conventions of the bond, the quoted price of a bond requires a series of complex steps to become the actual paid price of the bond, not to mention that, except for very few, bonds are rarely traded. Hence, it leads to an alternative to find the price of the bond, which is to use available market discount rates to discount the coupons and the principal of the bond. The two methods should be very close to each other, otherwise arbitrage should take place. In the next video, I will demonstrate how we can use an Excel spreadsheet to easily compute the Macaulay duration. In that video, I will demonstrate two methods to calculate the Macaulay duration, by using the formula and by using the numerical method. The numerical method is by adding a very tiny quantity to the yield, call it y plus, and recomputing the price, call it p minus. The Macaulay duration is simply the result of this calculation. The convexity is a further differentiation of the duration with respect to the yield. Consequently, we need two duration results, and hence we need both y plus and y minus. Previously, we have had the result of y plus. Now we do the same thing for y minus to get the bond price P plus. Now we can see that the duration, which is the slope, will change slightly up and down. Each slope is a duration, and convexity is the change of the slope. In the next video, I will demonstrate how we can use an Excel spreadsheet to easily calculate the convexity. The Macaulay duration is very popular, not just for its simplicity. It is popular also for its nice intuition and insights. The first insight is the formula. It is the weighted average of times, which is equivalent to the concept of payback time. The Macaulay duration tells you how soon an investor can get its investment back. The payback concept is very popular and important in capital budgeting when an investment is made. Investors are always concerned how quickly they can get their investment back before they worry about any profitability. The Macaulay duration does exactly that. Then we know that it is a sensitivity. Sensitivities are popular risk measures. Hence, the Macaulay duration is a risk measure. However, it is not a risk measure to any risk factor, but to its own yield, which does not make too much sense. Yet, empirically, the Macaulay duration represents a very similar sensitivity to those of realistic risk factors, such as key rates. We will talk about that in a minute. Last but not least, the Macaulay duration is similar to the fulcrum of a lever. Imagine that cash flows are weights being put on a lever. Then the position at which the lever is balanced is precisely the Macaulay duration. If the Macaulay duration is not a good risk measure, then what is? A good answer to that question is the sensitivity with respect to a chosen risk factor. So what are possible risk factors of a bond? As we talked about earlier, the price of a bond can be computed by market discount rates. Hence, when these rates move, the price of the bond moves as well. As a result, these interest rates are good choices as risk factors of the bond. These rates are known as key rates. For U.S. Treasury key rates, we can put out a website from the U.S. Treasury Department. There are 12 as of today. These key rates come from Treasury bills, notes, and bonds. It is another topic to go over various Treasury securities and how they are auctioned and traded. In the next video, I will demonstrate how to use these key rates to calculate the price of the bond and the sensitivities with respect to these key rates. Basically, it is a shock of each key rate one at a time and calculate the price change, as we did in the Macaulay duration. The most useful and practical duration for a fixed income security is by far the effective duration. The effective duration is simply defined over the whole yield curve moves. This includes shocks for off-the-run discount rates as well as the key rates which are on the run. To calculate off-the-run rates, we need a bootstrapping technology, which is also known as curve cooking. This is another topic altogether. So I will see you in the next video about Excel.